and today we are going to learn about the memory organization in Siemens. So for the memory organization, the memory bits are combining to form memory bytes, and they're combining to form the memory words, and they're combining to form the memory double words. So I'm going to show you how the memory can be organized in the Siemens. So I'm just inputting not the input variables, the memory variables. It is the bit memory. So 2-bit memory, MB0 and MB1. These are the memory bits, M0.0, M0.1, M0.2, 3, 4, 5, 6, 7, and then M1.0, 1.1, 2, 3, 4, like that. So let me show you how it's coming. Can show you. I just want to place one contact and one coil, just for showing the memories. Okay, one contact here, one contact and one coil. One contact and one coil. That will be M0.0. Okay, simply M0.0. And this would be M0.1. Okay, this will be M0.1 and M0.0. That's okay. And now we're going to talk about this memory organization and how it's coming. Let's download this thing, and let me show you how this memory bits. That memory bits means it can store only 1 and 0. That is called a bit. Okay, let me show you. M0.0. M0.0. Here it is. So let me make it online for you, and I'm gonna use the run, and we are at the runtime, and we can see M0.0, that is MB0, memory byte. Inside the memory byte we have MB0.0. See, that turns on MB0.1 also. Okay, these are the memory bits. These 8 memory bits combined to form a memory byte, that is MB0. These 8 bits, M0.0 here, M0.1 here, and 2, 3, 4, 5, 6 up to 7. That means 8 memory bits combined form a memory byte. So I'm not going for this. I'm going to show you MB0 and MB1. That's combined form the memory word. Okay, memory word 0. So I'm going to show you these two guys, these MB1 and MB0 combined form memory word MW0. So I can show you in the binary. So it's in the binary. You can see 1, and these 2 bytes or these 2 bits are the part of the second half. Okay, the second half of the memory bit. Okay, so let me make it clear for you. The first 2 bytes, see, the first 2 bytes of MB0.0 is here, and it's forming like this. Here you can see 1, 2, 3, 4, 5, 6. See, half of the memory word has been completed. And going to the next, 1, 2, 3, 4, 5, 6, 7, 8. All has been turned on. That means these 2 memory bytes are combining to form the 16-bit memory word. That is the MW0. Okay, so this is MW0, and let's see what happened if I combine the other memory bytes like MB2 and 3. So inserting 2-bit variables also, 1 and 2. See, MB2 and MB3, 2 and 3. So I'm gonna make another memory. That's for combination of the memory 2 and 3. That will be MW2. So after MW0, I'm taking MW2. Let's see why. So this is, you can see, same like this, 1, 2, 3, 4, 5, 6, 7, 8, 9. These 16 bits in the MB2 and 3, it's combined to form MW2. So where is MW1? MW1 is the half of the MB1 and the half of the MB2. That means the memory has been overlapped in between here and the half of the MB2 and MB1. So that's the trouble. So if you are using that memory MW1, okay, here it's MW1. If you are using the MW1, see, some values will be overlapped, so that you will be able to examine some changes in the value. So that I'm not using the MW1. We are using MW0, then we are using the MW2. After that we are using the MW4, then MW6, like that. And these two memory words are going to combine with one thing, that is the memory double word. That is called, we are making it as MD0, memory double word 0. See, that we cannot display in the decimal, in the binary. Okay, that can only be in the decimal. So if you are making everything 0, 0, and here also 0, that the whole combination of MW0 and 2 combines with MD0. After MD0, we will be taking MD4, MD8, MD12, like that. So this is the memory organization. This is how the memories are combined. You can see I'm just making the first bit of the, it's a 32-bit. MD0 is actually 32-bit. This 16 plus 16. The 16 are forming from MB2 and 3 16 bits. MB1 and 0 16 bits are combined. And you can see the first bit is on. Here you can see 1 1 1 1 1 3. See, like that. The values are incrementing from this order, 255, 551, like that. So this is the memory organization. So the total number of 16 bits is 6, or the total bits or the total data that can be saved in 16 bits. We can see it is 65,535, something like that. So let me clarify that for you. I'm just taking a calculator to make it clear. So you can see 2 to the power, we have 16 bits, and in each of every bits we can save zeros and ones. So we can go and 2 states, 2 to the power, we have 16 bits, 2 to the power 1 6. You can see 65,536, 535 and 536, because it is signed and unsigned, that one value will be changed. Okay, whatever. So what about it combines all these datas like this? So we can find the value for the 32 bits over the double word array, which is 42. It's a huge value, I think. So we can see 2 to the power 32, 3 2. We get the same. Okay, so this is the memory organization. We are using the memory word for storing the integers, and we are using the memory double word for storing and calculating the real numbers. So that is the memory organization. So we are taking MW0 after MW2, then 4, then 6, then 8, like that. That is a memory word. If you are taking the memory double word, you can take it as MD0, 4, MD4, and MD8, and MD12, like that. So this is a memory organization in Siemens.